All right, today we're getting into something really fundamental. We're talking about the very first step in creating an artificial intelligence. Because before you write a single line of code, before you do anything, you need a plan. You need a foundational design. You need a blueprint for a mind. So let me just start by asking you this. If you had to build an AI from the ground up, totally from scratch, where would you even begin? I mean, it's a huge challenge, right? But it's the exact problem that scientists in this field are tackling every single day. And to deal with that massive challenge, researchers don't just, start plugging away at their keyboards. They start with a design, a plan. They begin with the blueprint of a mind. Now, that blueprint has a technical name. It's called a cognitive architecture. And this isn't the part of the AI that's learning to play chess or drive a car. Nope. This is the underlying framework. It's the essential machinery of thought that stays the same, no matter what specific problem the AI is trying to solve. This quote right here is just the perfect way to think about it. Imagine a blueprint for a house. It shows you the foundation, the walls, where the rooms connect. That's the fixed structure. But it doesn't tell you what color to paint the walls or what kind of couch to buy. That's the contents. A cognitive architecture is exactly the same. It defines the structure of the mind, not the specific knowledge that's going to fill it up later. So if these things are blueprints, what do they actually look like on the inside? Let's crack open a couple of different designs and see how they're put together. First up is an architecture called Clarion, and what makes this one so interesting is its goal. It was built specifically to model and try to explain human psychological processes. So basically, it's an attempt to build a blueprint that actually thinks the way we do. Okay, so the core idea of Clarion is that our minds have these two different levels that are always interacting. At the top level, you've got your conscious, explicit knowledge. Think about the rules of the road you had to memorize for your driving test. But then, underneath all that is your implicit intuitive knowledge. That's your gut feeling, that subconscious sense of knowing exactly when to hit the brakes without even thinking about it. And Clarion organizes all of this into four key jobs. You've got an action-centered system for skills, a non-action-centered system for what we know about the world, a motivational system for our goals and what drives us, and then, on top of it all, a metacognitive system that's like the manager, just keeping an eye on everything else. But that's just one blueprint. For a totally different take, there's an architecture called Akira, which uses something called the energetic metaphor. Now, this one imagines the mind as a bunch of specialized little modules. They call them demons, and they're all competing for a limited amount of computational energy. So the more important a module is for the task at hand, the more energy it gets. It's almost like a competitive free market for ideas inside the mind. So we've looked at a couple of pretty different blueprints, right? And this brings up a really important question. Why so many different designs? Well, the answer is because there's no single right way that minds, whether they're artificial or human, solve problems. I mean, just think about yourself for a second. When you face a problem, are you the kind of person who needs a clear step-by-step plan? Or do you prefer to just jump in, try some stuff out, and maybe even change the problem itself as you go? How you answer that says a lot about your own cognitive style. And this isn't just some random personality quirk. This is actually a really well-researched field in psychology. One of the most solid frameworks out there is called Curtin's adaptation innovation theory, and it puts all of us somewhere on a continuous spectrum of problem-solving styles. On one end of this spectrum, you've got the adapter. Adapters, they love structure. They are masters at working within the current system to make it better, more efficient, more reliable. They're precise, they're methodical. Then, way over on the other end, you've got the innovator. Innovators prefer less structure. They're the ones who are way more likely to challenge the rules, to think way outside the box, and to solve a problem by just inventing a completely new way of doing things. And what's crucial here is that neither style is better than the other. They're just fundamentally different ways of thinking. Okay, so here's where we connect it all back. This whole adaptation innovation spectrum gives us a really powerful way to understand why those AI blueprints we looked at are designed so differently. It turns out that the design choices an engineer makes when building one of these architectures, whether to rely on strict rules or messy competing networks, those choices are a direct reflection of a specific problem-solving style. And when you actually map these architectures onto that spectrum, it all starts to click. Over on the adaptive side, you find these rule-based systems like SOAR and ACT-R, which are fantastic at working within existing rules. As you slide over toward the innovative side, you start to see architectures like Dual, which is designed for making creative leaps. And look at Clarion, sitting right there in the middle. Its hybrid design is literally trying to capture both that structured and that intuitive way of thinking.
So, what's the big picture? Why does understanding these different blueprints for artificial minds matter so much?
Well, let's wrap this all up. We've seen that cognitive architectures are the basic blueprints for building an AI. But, and this is the key, there's no single correct design. Instead, what we see is a whole spectrum of problem-solving styles, from the methodical adapter to the rule-breaking innovator. And maybe the most important takeaway is this. This isn't just about AI. By studying these artificial blueprints, we get a powerful new way of understanding the incredible diversity of our very own minds. And all of this leaves us with a truly profound question to chew on. As we get better and better at designing these blueprints, we're going to face a choice. If we can build AIs with distinct cognitive styles, some that are methodical improvers and others that are radical innovators, what kind of minds should we choose to create? And what does that choice ultimately say about us?